Well, hello again. In this video lecture, we're going to look a little bit at the process of solutes dissolving into solvents to form solutions. And as I was kind of reading this section in the textbook, I realized we could probably talk about this for a couple weeks. And so we're only going to touch a few points with regards to solubility. But at least it'll kind of give you a little bit of sense of what's going on when a solute dissolves in a solvent. And so we'll talk about that. We'll look a little bit at solubility rules for ionic compounds in water. And we'll talk about electrolytes and a little bit more generally at the end about when things will when a solute will dissolve in a solvent, and that last one's kind of going to more center on molecular compounds. Oh, and if I can click through this, we'll get through it. All right, so 97% of the water on our planet, we saw maybe a few lectures ago, is found in salt water in the oceans. And we want to talk about the process of ionic compounds dissolving in water. And so water is polar, and so what can happen if I have a salt like sodium chloride, okay, we're kind of used to it in its crystal form, and we might put it on our french fries or potatoes, okay, but when we add it to water, it starts to dissolve, and this is a little bit about how that happens. So water is polar, and it's going to have both partial negative and partial positive charges on it. And the oxygen atoms, shown here in red, have partial negative charges. And so they're going to be attracted to the sodium ions in sodium chloride because the sodium ions have a plus charge. Okay. At the same time, we have the partial positive charge on the hydrogen atoms in water, and they're going to be attracted to the chloride ions because they have a negative charge. Okay, and so this process results in the dissolution of the salt, and we can show that maybe with a formula here, a chemical formula for sodium chloride dissolving in water. So sodium chloride solid, when it dissolves, we form aqueous sodium cations and aqueous chlorine anions. So that means aqueous means it's dissolved in water. Okay. This can also happen with polyatomic ions. So a polyatomic ion is an ion that has more than one atom in it. And an example of that is the sulfate ion. It has sulfur and oxygen. So these can also dissolve, all right, to form, so sodium sulfate can dissolve to form sodium ions and sulfate ions. All right, so people have kind of looked at different types of ionic compounds and different types of ions to see, are they soluble in water or are they not soluble in water? And they found certain trends, and based on those trends, they made what's called solubility guidelines or solubility rules. And so I want to go over that in this slide and see if we can predict, using these rules, which compounds will be soluble or not. Okay, so I'm going to start by kind of going through this table and how we might use it. So if our ionic compound contains sodium, potassium, or ammonium ions, any compounds that have these ions are going to be soluble. And there's not really any exceptions to this. Okay, so some examples here are sodium nitrate. So NO3 is the nitrate anion, so that's going to be soluble. Oh, actually, but we're talking about sodium here. So sodium, it contains sodium, so it's going to be soluble. And potassium bromide contains potassium, so we'd expect that ionic compound to be soluble. This also applies to nitrates. All ionic compounds that contain nitrates are soluble. So examples would be lithium nitrate and magnesium nitrate. Okay. If an ionic compound contains a chloride anion, those are mostly soluble or usually soluble. However, there's a couple exceptions. So if it's a silver chloride or a mercury chloride, it's going to be insoluble. So some examples: magnesium chloride would be considered soluble. Sodium chloride, however, would be an exception because it has that silver cation. All right, let's look at sulfate. So this is another type of anion. So this is our SO4 2-. These are usually going to be soluble except when the other ion is strontium, barium, or lead. Okay, so potassium sulfate would be soluble. However, barium sulfate would be insoluble. It's an exception because it has barium. All right, let's look at carbonates. So carbonates are mostly insoluble. Okay, but some exceptions would be group 1 metals. Okay, that's like our sodium or potassium. And ammonium, compounds that contain ammonium are going to be soluble. Okay, so sodium carbonate is an exception. It's going to be soluble in water because it contains sodium, which is a group 1 metal, whereas calcium carbonate is going to be insoluble. Okay, and then lastly, let's look at hydroxides and sulfides. They're going to be mostly insoluble. And again, some exceptions could be group 1 metals and ammonium cations. So potassium hydroxide, that's an exception to the rule because it contains potassium, which is a group 1 metal. Aluminum hydroxide is not an exception because this is not a group 1 metal. Okay, so what I'm going to do here is I'm going to show you some examples here, and I want you to predict, I want you to pause the video and predict, are each of these going to be soluble or insoluble in water? And then in a few seconds here, I'm going to go over the answers with you. All right, so let's go over these answers. Calcium nitrate, that's going to be soluble. The reason it's going to be soluble is it has a nitrate ion, and all ionic compounds that contain the nitrate are going to be soluble. All right, how about this one? That's going to be insoluble. So this is strontium sulfate. If we look at our sulfates, they're mostly soluble. However, strontium is going to be an exception. Since this is strontium sulfate, it's an exception, and it's going to be insoluble in water. All right, how about magnesium hydroxide? That's going to be insoluble. Let's look at our hydroxides. So hydroxides are usually insoluble. Magnesium is not one of our exceptions, so it's going to be insoluble. And then lastly, potassium chloride. Potassium chloride is going to be soluble in water, and for 2 reasons. One, it has potassium, okay, and we know that all potassium compounds are soluble in water. It also contains chloride, and chloride is mostly soluble, with some exceptions being silver and mercury. Potassium is not one of the exceptions, so potassium chloride is soluble in water. Now you may notice here that there are some things that we learned before that you kind of have to know to actually do this. So one, you kind of need to recognize that, for instance, that SR is strontium. You need to go back and forth between chemical symbols and names, and also names of ions and their symbols. So like NO3, NO3 minus, you need to know that that's nitrate to apply this table. Okay, great. All right, so let's move on. Let's talk about electrolytes. Okay, So electrolytes have to do with electricity and electrical conductivity. And it has to do with ions. So when ions, which are charged particles, are in aqueous solutions, they are able to conduct electricity. Okay. And so an electrolyte is something that when it's in water, it makes the solution conduct electricity. All right, so let's look at 3 different examples of liquids and whether or not they're conducting or not. So if we take pure distilled water, it's non-conducting. Okay, so and this is supposed to kind of show that. So what we've got here is a battery, which is a source of electricity, and a light bulb. And when we're trying to run that electricity through water that's pure and distilled, no ions in it, the light bulb does not light up. So that means it's not conducting electricity. Okay, so here's another scenario. These blocks are supposed to be sugar cubes, which they probably are. Okay, and it's supposed to tell us that we've got sugar dissolved in this water. And you can see the light bulb is not on, so that means sugar water is non-conducting, and that sugar is a non-electrolyte. Okay. However, in this third picture here, you see the light bulb is on. Okay, and the reason is we've got some salt here, and that's supposed to tell us that we have salt dissolved in this water. And salt, sodium chloride, salt water is conducting. And so that tells us that sodium chloride is a strong electrolyte. Okay, great. So basically compounds, when they're ionic compounds and they dissolve in water, they're going to be electrolytes. All right, so we can have strong and weak electrolytes. So if a compound completely dissolves in water, that's going to be a strong electrolyte. If it partially dissolves in water, it's going to be a weak electrolyte. And then if a compound dissolves in water but does not dissociate into ions, it's a non-electrolyte. So this is an example of a sugar molecule. And it will dissolve in water because it's polar, which is kind of getting onto the next slide here. But it doesn't dissociate into ions. So it's a non-electrolyte, this sugar molecule. All right. So another thing we can talk about, another concept with solutions is this principle of like dissolves like. Okay. And we can get some things from this. So a polar compound like ethanol will tend to dissolve in a polar solvent, and they're like each other. So the ethanol will dissolve in the water. Okay, so and this is kind of an example of why the ethanol can dissolve in water. It's polar, and also it can hydrogen bond with water molecules. A nonpolar molecule will tend to dissolve in a nonpolar solvent. So oil could dissolve in gasoline, as an example. However, a polar compound like water will not dissolve in a nonpolar solvent. Okay, and vice versa. Okay, so oil and water don't mix. They form 2 layers. Okay, and here you can see the oil is less dense than water, and so because they don't dissolve in each other, or because the oil doesn't dissolve in the water, we have 2 separate layers, and because it's less dense than the water, it floats on top of the water. And this is why we can get oil slicks when oil spills in water. All right, and that's gonna conclude this lecture on solubility, and thanks for watching.